when we're considering identifying out of this lineup of molecules, which ones are only hydrogen bond acceptors, we're looking for a situation where the molecule contains one of our three nitrogen, oxygen, or fluorine atoms, but they do not have these atoms bonded to hydrogen. So anything where, in the case of nitrogen, we can have three other groups bonded to that nitrogen, as long as they're not a hydrogen atom, this will make it an acceptor-only situation. Same way for oxygen. So any oxygen molecule in which that oxygen is bonded to two other carbons or any atom other than hydrogen, that gives us an acceptor-only situation. And so as we survey our series of options here, we can see that in the case of molecule A, we have a nitrogen atom. This is good. So we have a lone pair that can accept a hydrogen bonding interaction. Let's say another nitrogen containing compound in which we have a nitrogen-hydrogen bond. And so we're able to accept a hydrogen bond only through this molecule because it lacks any nitrogen-hydrogen bonds on it. So we can just work our way through these options and only select the ones that feature nitrogen and oxygen without any hydrogens bonded to those atoms. And so in this case, based on that, A is going to be 1. In the case of B, we have an oxygen-hydrogen bond, so that won't work because it's also a donor. As you go to C, we have oxygens bonded to other carbons, but there are no OH bonds. So this would meet the criteria of being an acceptor, but not a donor. In the case of D, we would not select that one because we have an HF bond and it's able to do both. For E, this molecule is entirely hydrocarbon, so it lacks any ability at all to form hydrogen bonds because it's only a hydrocarbon molecule. We go over to F. Now we have a molecule that has an oxygen. It has the requirement for possessing that oxygen atom without any OH bonds, and so for that reason, this would only be an acceptor. Same is true for G. We have our requirement for an oxygen atom, but without any hydrogen bonds, G will only be able to form hydrogen bonds as an acceptor. Same way for, in the case of H, now we have an OH bond. This molecule is capable of doing both. In the case of I, this again, if we look at the skeletal drawing shown here, this is entirely hydrocarbon, so there's no hydrogen bonding whatsoever in this molecule. Going to J, this is aniline, and it has NH bonds, so it is capable of being both a donor and an acceptor. In the case of K, this is a situation where we have the nitrogen with no hydrogen bonds and oxygen as well, not bonded to a hydrogen. These are both acceptors for hydrogen bonding. And last, in the case of L, for this ether, this molecule lacks an OH bond. It has the oxygen with the lone pairs, so it can be an acceptor, but it is not a donor. Okay, so for that reason, in our lineup of molecules, we would select A, C, F, G, K and L.